everyone. I'm Andrew, an undergrad studying computer science.
Hello, everyone. My name is Abhijit, and I am a third year computer engineering student.
Hi everyone, my name is Juan. I'm fourth year computer science major student. We are a team of the particle transformer. In the beginning, the scientists would like to analyze the particle jets data that generated by a big collider. They would like to do the classification and figure out what kinds of data was being generated. But the issue is that the collider will generate a bunch of jet streams per second. There is no way to store all of them. So they use the particle transformer model to do the classification and only store the classification result. However, we find that the particle transformer model is not fast enough, even though it's running based on GPU. So we find that FPGA might be a better solution because theoretically, FPGA will be faster and more efficient compared than the GPU. But the problem is that the API we use to implement the model into the FPGA called DeepSoCFlow, this API only supports Q-Keras. So our target is going to be make the model compatible with the API by implement using Q-Keras.
So here are the different steps of our project. So the first step was to run the original PyTorch model for the particle transformer and try to validate the results the researchers got. The second step was to implement a model called NanoGPT in PyTorch. And the idea behind this is that it was kind of an analog for the particle transformer model, but just a little bit more simple. So we're going to use this as a proof of concept and as our MVP. Step 3 was to do the actual particle transformer translation. So taking that model from the PyTorch implementation, re-implementing it into Keras. And then step 4 was using QKeras to quantize that model. So essentially lowering the bit width of all the different model parameters to make it a little bit faster and more efficient. And for step 1, this went very well. We were able to achieve around 85% validation accuracy, which is what they had in the paper. So we're really happy with that. The one casualty was our TA Zhenghua's server, who we maxed out the storage on. So he was a little sad about that. Step 2, this was implementing NanoGPT in PyTorch. This went very well. Use this as our MVP. And we also did a PyTorch to Keras translation, practicing all of the different steps that we're going to have to do to go from PyTorch to Keras for when we did it for the particle transformer later. This video shows us training the NanoGPT model and then a little bit of its output, as you can see here. It's just taking in some Shakespeare and then outputting some Shakespeare of its own.
The next step is the particle transformer translation from PyTorch into Keras. This is where we faced our biggest challenges. In the end, we have a Keras implementation, but with only a training accuracy of 25%. Here is a video showcasing the training of this model. And as you can see, the training accuracy never really goes above 25%. And for reference, the original PyTorch implementation has an accuracy of over 85%. Clearly, this is not good enough. We underestimated how different TensorFlow is compared to PyTorch. For example, this is PyTorch Advanced Indexing. And this is the same thing in TensorFlow. Clearly, there's a big difference. And for your amusement, here's another error. Some more. Some more. Some more. Yeah, basically, there are a lot of complexities. The next step is quantization. Because step 3 took so long, we never really got started with this step, and as of right now, with our initial efforts, we're running into some memory errors. This is a work in progress. What are the future steps? Debug and improve our Keras model, and then use QKeras to quantize this improved model, and also implement the model on an FPGA using DeepSoCFlow. This was our original stretch goal at the beginning of the quarter. Thank you for watching.